Let me ask you, how many of you are charging your phones or tablets or whatever else every day? Twice a day? 3 times a day? Oh, there are people 3 times a day. Really? Okay.
Who does it once a week? Oh my God, I want your phone.
You understand, when you have your phone running out of the battery, you cannot post your nice pictures to Facebook, you cannot tweet, you cannot talk to your mom. You can do nothing because you're running out of the battery. And obviously, there are many ways to charge your battery, like use your solar power, use salt water, use coffee, fruits, whatever, food, and obviously just the regular AC outlets. But reality is that over the years, what we call power gap becomes bigger and bigger. So power gap is basically the difference between what we need out of our phones in terms of the energy and battery life and what they really have. Obviously, that battery life of any device is increasing because the technology becomes better, but it doesn't become that better like we need it. And we have a lot of apps, and all applications need energy, need battery. And when we start thinking about different aspects of battery usage, we can have 3 big aspects, three kinds of criteria. The first criteria is regional differences. On some markets, they use very cheap phones, really popular, and those phones don't have good batteries. We also have different quality of cell networks, because some networks really eat your battery. You probably notice it sometimes. There are also different devices. We have devices with big screens, we have devices with small screens, and it's also about the different software and your habits. Like some people play games, some people do social applications. So you as developers, should consider all these factors when you're building your apps. Windows 10 universal platform really cares about how your applications use your battery. And the Windows itself also cares about your battery, and we are trying to design all our APIs as well as applications to be to respect your battery life. And we basically ask you, and we as Microsoft people, as well as just users, please code smart. Consider how you use the battery, how you use memory, how you use CPU. And basically, I'm going to show you how you can use universal Windows platform capabilities as well as just Visual Studio debugging and profiling capabilities to optimize your applications for battery usage. This is going to be my demo, and I want to switch to number 6. Awesome. This is a very simple application. We have some universal Windows APIs for tracking battery state, as well as understanding how much memory are we using, how much battery are we consuming. Let's start from some simple events we have. So here I have a simple piece of code, and you can see that I can basically understand if my device now is in charging mode or it's on battery, and even this simple thing gives you a lot in terms of behavior of your application. So you can say, okay, if I'm in charging mode, then I can do more. I can engage high quality assets like images with high resolution, and etc. If I'm in battery mode, then I should probably be not that hungry for resources. Let's just run this application, and I'll show you how it works. So first, let's just talk about if I'm in charging mode or not, about all these events. So I'm going to unplug my surface from the battery, and you say, I'm in discharging mode. It's like, it's here. I plug it back. I don't want to run out of battery. And eventually, yeah, and I'm on idle. I'm not charging because I'm at 100%, but I'm in idle mode, so I'm just not consuming the battery. The second thing, which is also interesting, we have these debugging and profiling capabilities in Visual Studio, and it's very helpful for you to understand how you consume memory and CPU. And let's just show how it works. So I have this memory report and CPU report below it, and let's try to do some very simple calculations like this. You see that CPU utilizations had a small spike. That imagine I need to load some resources like images. I click load images, and you see a small spike with the memory usage. But if I'm trying to calculate something really cool and something like pie calculation, let's see what's going to happen. I click this button, and you see a huge spike on CPU. And basically, all this information I can get from not just profiling tools, but also from Windows Universal Windows APIs. And I can use it over in my application to understand how I'm doing in terms of the battery and resources, so I can optimize scenarios. This is how it works. Let's switch back to the slides. So basically, the question is, are you targeting low-end devices with your application? If yes, then consider that they may have very limited resources. By the way, it's not just about the battery, but also about memory. Be smart when you're doing background tasks. There is capability for doing background tasks. Try to use it, but also consider that there are some limitations for background tasks when you're running in the battery-saving mode, for example. Care about resources like asset size, like images size. If you have different resolutions for your images, that's very good because you're going to optimize your application for different modes and different kinds of resolutions and device capabilities. So optimize your code, profile it. Now we have great tools for this, and please use this opportunity to be good for your user. This is it. Thank you.